Now we're going to start the vector addition. You're going to do it two ways. First we're going to do velocity, and then we're going to do the displacement. Alright, so velocity, we're going to draw exactly the same thing you see over there. And the displacement, I'm going to draw exactly the same thing at view over there. And I'm going to remind you this is the dt graph. And I'm going to remind you this is the dt graph. And I'm going to erase everything. I'm going to erase the coordinate plane. I'm going to erase the coordinate plane. You don't need to see that. So at location 1, I have one vector. At location 2, I have another vector. Okay. Location 2, I have another vector. At location 3, I have another vector. This green vector is 16, 16, 16. Over here is 0. And this red vector is negative 12. Okay. So we're going to focus our attention at location 1. This purple color. So the purple vector, what is the purple vector? 1. This is Vx. And this is Vy. And this is V initial. All right. So I'm going to call it vector 1, 2, and 3. So Vx, I'm going to call it vector 1. Vector 1. Vy, I'm going to call vector 2. So I'm going to take the vector 1. Before I do that, I just want to describe the vector. So the vector has two property, red and purple. The red one is magnitude, and the purple one is direction. The magnitude of this vector is I think is green. So let's make it green. I'm drawing this one. Let's make it green. Alright, so the magnitude is 16 and the direction is to the east. This is head. This is head. This is called tail. I'm going to show you the head and tail method. So I'm going to take the vector 1. I'm going to put the vector 1 over here. And I'm going to find the tail of the vector 2. Tail of the vector 2. And the head of vector 1. And I'm going to write their magnitude. And I'm going to add them. So from tail to head. I'm going to use the purple to do that. Okay. This is Vx, this is Vy, and this is V initial. Or this is A, this is B, and this is C. Okay. Now, how can I add these two vectors? 16 plus 12? No. Why not? Because this green vector and this red vector are not at the same direction. If you put them on the same direction, then 16 plus 12 is in fact 28, but they are not at the same direction, so you cannot do it this way. So you have to use the Pythagorean theorem. So then what are you going to do? You're going to use c square is equal to a square plus b square. So c square is equal to v square 16 square 12 square. So then v is equal to 400. So then v is equal to 20. So this is 20. We already know, then this is 20. Then this is 20. All right, so I'm gonna now show you the displacement. So the displacement right here, we want to find the displacement right here by Pythagorean theorem. So displacement at location 3, dx square plus dy square. So total displacement at location 3 would be dx is 38.4 square plus dy at location right here is 0. So the total displacement is 38.4 square. So this cancel. So the total displacement is 38.4. All right. Now the homework is you're going to find the displacement. So if I put a point over here, you're going to find the displacement right here. Right here. When the time is, so I'm going to draw the vector. It's very hard to draw it. All right, right here. So what is the displacement right here? So the displacement right here. What would be the displacement right here? dx square plus dy square. Okay, so you're going to find it right here, displacement right here. And displacement right here would be like that. 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 Okay, but I want you to find the displacement right here. I'm going to give you the time. When the time is 2.3 seconds, just before the ball hit the ground. That's the homework.